Okay, so we're now going to talk about the idea of resultant force. Okay, this is a key idea for Newton's laws. So resultant force. So let's say that we've just got, I can't draw very well, so I'll just draw a box. Here's a box. Okay, this box here has a force of, I don't know, let's say 3 newtons acting that way. Okay, and it has a force of 3 newtons acting this way. So the force to the right is 3 newtons and the force to the left is 3 newtons. Now, by the way, we measure forces in newtons, okay? So the force is measured in newtons, and that's named after Sir Isaac Newton, who came up with Newton's laws, okay? So forces are measured in newtons, and the symbol for that is capital N, okay? So 3 newtons is the force to the left, 3 newtons is the force to the right on this box. Okay, so the resultant force on that box, although there's 2 forces acting on this box, they're the same force in opposite directions, so they cancel out. So the resultant force acting on this box is actually 0 newtons. Okay, you could redraw it like this. Okay, that's basically what's happening, because there's one force this way and one force this way. They're the same size. Essentially, that they cancel out, and the resultant force here is 0 newtons. It's a bit like in a tug of war. If one team is pulling the rope to the right and the other team is pulling it to the left, if both teams pull with the same force, the rope doesn't move. Okay, it just stays in its same position. Alright, now if you look at another box here like this, let's say this one, okay, let's say there's 5 newtons this way, whoops, and there's 2 newtons this way. Well, you can see in this case the box isn't going to move, okay, because the 2 forces are balanced, there's no resultant force, that box just won't move. In this case, it's pretty obvious, hopefully, that the box is going to move to the right. And the reason for that is that there's a resultant force to the right, and that resultant force is this force take away that force. Okay, to work out the resultant force, we take these 2 forces away from each other because they're in opposite directions. So 3 take away 3 gives us 0. 5 take away 2 gives us 3 newtons to the right. So there's a resultant force here of 3 newtons to the right. Okay, and that means that this box here will actually start to move. It will speed up. It will actually accelerate. Okay, this box will accelerate to the right. Okay, so that's how we work out resultant forces. Now, what if we've got, let's just draw this. Let's just say this is like a box car. So there's this car like this, okay? Excuse the shocking drawing. Let's say it's already moving this way at 2 meters per second. It's moving to the right at 2 meters per second. And there are 2 forces acting on it. 3 newtons this way and 3 newtons this way. What's the resultant force on that car? Well, the resultant force, as you know, is 0 newtons. And as a result of that, that car will just stay going at the same speed. So it will remain at a speed of 2 meters per second. Okay, so if there's no resultant force acting on a box and it's not moving already, it will just remain stationary. If there's a resultant force on a box that's not moving, it will accelerate in the direction of that resultant force. If there's no resultant force on an object that's already moving, it will just remain at the same speed. Okay, so you might think, well, why do things slow down sometimes? When you push an object and let go of it, why does it slow down? Well, that's because of the force of friction, okay? If there was no friction, it would just carry on at the same speed. That's why when you skate on ice, if you stop pushing, you basically carry on at roughly the same speed because there's no friction, okay? So that's what happens with objects, right? If there's no resultant force, the object will either stay stationary if it's not moving or carry on at a constant speed. If there is a resultant force, the object will accelerate in the direction of that resultant force. Or, there is one more example, okay, if we turn this over. Let's say that you've got this terribly drawn car again, okay, and let's say it's already moving this way at 2 meters per second. Let's say there's a force of 3 newtons acting this way and 1 newton this way. So the resultant force on this car is now 3 take away 1, so it's 2 newtons to the left. Okay, it's it's got a resultant force to the left, but it's moving to the right. So what will happen to this? The car will decelerate or slow down. Okay? It will decelerate or slow down. So those are the main ideas really with resultant force. Okay?